Next up, we have Haddi. Haddi will talk about blocking JavaScript without breaking the web. Thank you, Haddi.
Okay, hi everyone. Sebastian, great talk. So I'm Haddi, and today I'll just talk about how content blockers can deal with this large amount of JavaScript on the website. So basically, this is about the paper, which is an empirical investigation about blocking JavaScript without breaking a web. This is in collaboration with the UC Davis team and in Virginia Tech. And yeah, I'll spend some couple of time on formalizing the problem first, and then we can just discuss some conclusions and results as well. Okay, so let's just talk about some of the trends. So the volume of JavaScript has been increasing steadily over the years. So according to the WebLMNAC year-to-year analysis, if we see it's from 2019 to 2020, it was 13.4%, and followed by a 12.1% increase from 2020 to 2021. And there was a 10% increase from 2021 to 2022. So in short, in 2022, web pages ship over 500 kilobytes of JavaScript on the web pages. So this is insane. Yeah, you just heard it right. So this amount of JavaScript, this is an absolute marvel, and this would obviously won't have any effect on the website's performance. So good luck with your website's performance. And slightly the more spicy part about, because since most of the people sitting over here is from somehow privacy related, so let me tell you an interesting thing about this amount of JavaScript. The half of this JavaScript is coming from these third-party script providers. Now, you know, these third-party script providers are just going out of their way to be so generous. Like, I mean, who doesn't like this amount, this dazzling animations on the web pages and fancy UI stuff? And there is like small chunk where they start doing this behavioral tracking, which is like, it's so less, and how thoughtful they are in itself. So you just innocently click on a Nike shoes ad, and then you suddenly blessed with a bunch of absolutely fantastic ads on all over your Instagram and Facebook feed. Now it's truly a dream coming true, right? So now, obviously, now just keeping jokes aside, so we have one big problem over here. That's a behavioral tracking in this amount of JavaScript. And consequently small, yet a very active web users community is just trying to figure out some solutions to address this. So today I'll just talk about how we can address this JavaScript issue specifically. So the first question that comes to our mind is what status quo has to offer, and then we can talk about what are, you know, the loopholes within the status quo and how we can address them, and that's slightly more future work, which we can discuss later. So the first setting is, so we'll discuss 5 different settings in the JavaScript. So the first setting is you do not do anything, you just go with it, which is obviously not advisable because it will have a compromised security and privacy concerns. Second, which is slightly more nuanced option, and this is adopted by most of the content blockers used by people sitting over here, like AdGuard, uBlock. And they just simply block the tracking scripts and let go the functional ones. Now the problem comes in that, however, there is 1/3% of the web users are using these content blockers. So there is like strong incentive for these trackers to, you know, evade these kind of content blockers. So this is an ongoing arm race, and this is never-ending strategy. So in this whole atmosphere, we have seen a new evasion strategy which has emerged, where developers start mixing the tracking and a functionality in a one single JavaScript. And sometimes it's unintentional when you are using some Webpack bundlers or Browserify. It automatically bundles a bunch of analytic scripts and some of the functional scripts into one script and just, you know, send it to the website client side, right? So sometimes it's intentional and sometimes it's unintentional, but it is getting to a problem now. So one option is to, you know, just block these mixed scripts as well. Block tracking scripts, block these mixed scripts, and see what happens to the website. And to this, and there is an alternative approach to address this mixed script issue is to, you know, instead of blocking the whole script, you can just be specific about the tracking functions within these scripts. And you just go after those tracking functions within those mixed scripts and block those mixed scripts. And this is referred as method level JavaScript blocking. And the last option, which I think most of the people in the poster session actually came to me and asked, is like, why don't you just block all JavaScript on the websites? And this is pretty much also some of the default features by browsers, and there is some tool-based extensions like NoScript, which just simply block everything on JavaScript. We can discuss this, but again, it has some pros and cons, but let me just take a more concrete case study to just evaluate all these 5 approaches that we have. So let's talk about a website, livescore.com, and take these 5 configurations one by one and discuss these. So the first one is obviously we do not block everything. We see multiple advertisements on the web page. There is on the background, we see tracking going on. Everything looks perfect, website is usable. And this is also the control setting for later on when we talk about the automated analysis. Just pointing that out, that this is the normal configuration. And obviously it would have some privacy concerns on the long-term consequences. So the second option was slightly more selective approach, where we just go after blocking the tracking scripts, and this was selective JavaScript blocking, and we try to block simply the tracking scripts within the website. At first, it seems so promising, right? There are no advertisements on the web page, website is working perfectly fine, and you are using uBlock Origin, AdGuard, and it looks so good. But the problem is we have to acknowledge that there are mixed scripts which slip through these filters, and there are a bunch of exception rules out there, even in the easy list and easy privacy and a bunch of other filter lists, which are still not blocked by these uBlock origins just for the sake of functionality. And do you want to see on how? Let's just go in details. So yeah, so on the website livescore.com, we have seen a mixed script app.js. There was a long app. And then identifier.js, but in short, we can say app.js was the script. And this was a mixed script. Why? So this was a mixed script because it was just setting up a tracking cookie on the web page, along with some of the entangled in the functionality of the web pages, which was loading some statistics on the home page of the website. So now it's a problem for content blockers. Either you can block the script as in whole, or you can just let go. So this was one of the scripts. This was not being blocked by the uBlock Origin or some scripts like that. And so the third approach that we try to evaluate is what happens if we block such scripts in the website. This is simple trade-off between functionality versus tracking. Or the other approach by which we can try in this case was, instead of blocking, but before that we jump on to, let me just explain one more thing, that we also conducted a longitudinal experiment over these mixed scripts, how these mixed scripts are increasing over the time. And the interesting part was, over the 1-year interval, we discovered that there is significant 14% increase in the utilization of the mixed scripts among the 100K websites. So again, the problem is so big and it's growing over time. Either it's unintentional or intentional, but this is a problem that we need to address. So the other approach that we proposed alternatively could have been to just focus on the tracking functions within those mixed scripts. For instance, in the mixed script app.js, we wouldn't simply block the tracking method. For example, method 2 was the tracking method that was setting the cookie, and we can just let go all the functional methods so that they can just load normally in its space. So the last ultimate option, which most of the people would come and ask me, and sometimes they also want to address with this large amount of JavaScript, is to just block everything. Just don't let go anything JavaScript. So the problem is websites have developed and they have a simple check out there, and they won't let you use the website at the first place. For example, in this case, you can see there is a user prompt which is telling the user to unblock the JavaScript in case if they want to use the website. And there are a bunch of such cases where, while this extreme option may seem appealing for addressing the excessive JavaScript issue, but it proves unhelpful as it renders many websites unusable. Now that we have a concrete case study to see how these 5 configurations look like, let's just take a deep dive and see and magnify this whole 5 configurations in the form of automated analysis that we conducted. And then we can talk about the results of these. So before that, we have to conduct some sort of, we have to have some breakage metric to identify, because in automated analysis, it's, I think, the most hardest job. And to perform this benefit analysis, we just came up with the metric. For tracking quantification, we compared the number of tracking requests in the blocking configuration against with the control configuration that I discussed earlier, where nothing is blocked. And for breakage quantification, we count two things. One, we count the number of functional requests missing on the web page as compared to the control configuration. And the second thing that we look at is the DOM, the missing URLs from the DOM, and we just try to compare the URLs that are being missing with the filter list. If it's advertisement, it would be caught by those filter lists, and if it doesn't, then this is a functional breakage on the website we consider. And later on, we also do some for false positive analysis. We also have complemented it with some manual breakage analysis, which I'll discuss later in the slides. So let's discuss one by one the results of these 5 configurations on the automated analysis. So this is the control setting. Nothing is blocked. Everything looks good. And this is the per web page request counts. The second option we had was, which is mostly adopted by current status code tools, is selective blocking, where we block tracking scripts and let go the functional ones. In this case, we still see 53% of the tracking requests on the web page, resulting in 11% decrease on the functional requests per web page. However, we need to remember that this still let go mixed scripts at the first place. So although this approach is most safest one, but it still incentivizes to mix tracking in the functionality to avoid such kinds of tools. So the second option that we want to discuss is what happens if we block those mixed scripts as well along with the tracking scripts. So just to quantify breakage associated with these mixed scripts, we also evaluated the when we blocking mixed along with the tracking scripts. This reduces the tracking request by 62% per web page, but also causes 18% breakage in the functional request count. Now we evaluate the fine-grained method-level JavaScript blocking, which reduces the tracking request by an average of 63%, better than the state-of-the-art which we have, which has 53. And along with it, we also see only 12% decrease in the functional request count, which is very close to the status code, which was 11%. Lastly, we have a blanket JavaScript blocking, where we block every JavaScript that exists, and the results show that on average it decreases the tracking request counts by 70% per web page, but again, it also leads to 65% decrease in the functional request count. Unfortunately, this means that we cannot block all JavaScript at the web pages, and we see this small request because some of them just slip through the no script filter that we used in the experimentation. Lastly, we complement the results for the false positive analysis. We also did some manual inspection on the websites. On 383 websites, we just did on 2 major configurations, tracking and mixed JavaScript blocking and method-level JavaScript blocking, because we wanted to compare that if mixed resources are being blocked, is it a big problem for the websites? And if we try to go on method-level JavaScript blocking, does it solve the problem or not? So during the inspection, we categorized the website breakage into 4 categories. Navigation is the first one, where we talk about the internal web pages. Appearance, self-explanatory. We exclude the advertisements. We just keep the web HTML elements. Single sign-on, user sign-in, and additional functionality includes everything other than the above 3 categories. Last, we have we have breakage in 3 levels. No breakage means everything looks good. Minor breakage means there is some abnormal behavior, but it's still usable. And major breakage means there is significant breakage on the websites. So the results of the minor breakage were on 383 websites, 15% of the websites have a minor breakage when mixed JavaScript was blocked, and only 9% of the websites show minor breakage when method-level JavaScript blocking was enabled. And we also find that on major breakage, 26% of the websites have a major breakage when mixed JavaScript was blocked, while only 7% of the websites have major breakage when methods were blocked instead of the mixed scripts. In short, we see less breakage in method-level JavaScript blocking as compared to track and mixed JavaScript blocking. So quickly, I'll just go through the quick takeaway. In a status quo, we have 2 options. One, we can go extreme. We can block everything, but still websites will be unusable. The other option that we have is a selective JavaScript blocking. You let go those mixed scripts and let the tracking go away from it. So the solution that we see in the future is in the form of the method-level JavaScript blocking. Again, we did not propose any tool in this paper, but in the future work, which we try to, there is a complete end-to-end encryption, end-to-end pipeline, where we have a machine learning classifier to detect these tracking functions. And at the end, we have a surrogate replacement scriptlet for these mixed resources as well. Thank you. I'm happy to take any questions.
Thank you so much, Haddi. So we have a question. We have several questions, and one of them is why? I'm sorry. The first, like, did you analyze how much of the functional, I guess, like functions were essential for working with the websites, and these could be selectively blocked? Okay, maybe I'll skip that. For the website that has major breakage with method level blocking, what features were impacted?
Okay, so in major breakage, the most important thing was the navigation and the appearance. In SSO, we have seen very less, but yeah, navigation and the appearance were the two key. And in appearance specifically, we saw the CSS was messed up, or yeah.
And another part of the question, which I'm also very curious about, could this be adversarially used to, you know, I'm a tracker, I add some like a functionality to my methods?
Yeah, so again, it's a very great question, and I think we cited the number in the paper where we have seen like some of the methods as well mixed, which were performing both activity. But in that case, I think the future work we have in place is we'll just do some call stack analysis, and we'll figure out that even if we don't block that mix function, there should be some chain in a connection which solely be doing some tracking activity, and we can just simply block that tracking function to make sure there is a dependency chain should break, and the activity should be
Thank you so much, Haddi. Maybe another applause for him?
Thank you so much.